Okay, so hello everyone. So we continue with MCQs. This is a continuation on the first video on MCQs on string pipes, string, open pipes, and closed pipe. Okay, so number 15. In an open pipe of length 1 meters, the fundamental frequency is, and we are given the velocity of sound in air. Now the fundamental frequency in an open pipe is V over 2L, the speed over 2 times the length. So that is 340 over 2 times the length of the pipe is 1. That is 340 over 2. That is going to be 170 hertz. So B is the answer to this question. Now the second one says, in a closed pipe of length 1 meters, the fundamental frequency is. In a closed pipe of length 1 meters, the fundamental frequency is. The fundamental frequency in a closed pipe is V over 4L. That's the formula for fundamental frequency of a closed pipe. And so the V is 340, which is the speed of sound in air. Then we have 4 times the length of the pipe is 1. So this is 340 divided by 4. That's going to give us 85 hertz. So the answer to this question is A. Now the next one says, nodes are points where the answer to this question. A says displacement is maximum, B says displacement is 0, C says frequency is high, D says energy is maximum. The answer is that displacement is 0. When you have a stationary node, it only appears on a stationary wave like this. So these are nodes. At this point there is no displacement. This is where you have maximum displacement, which is the antinode. So this is called the antinode and this is called the nodes. Okay. So number 18, antinodes are points where displacement is maximum. B. Okay, so antinodes are points where displacement is maximum. Now 19, the speed of sound in air increases with A. Decrease in temperature, B. Increase in temperature, C. Increase in pressure, D. Increase in humidity only. Okay, so the answer to this question is increase in temperature, because the speed of sound in air is directly proportional to absolute temperature. So directly proportional simply means as temperature increases, the speed will also increase. Okay. Now number 20, a pipe open at both ends resonates when A. Nodes forms at both ends, B. Antinode forms at both ends, C. Nodes at one end only, D. No standing wave form. The answer is B. Antinodes forms at both ends. Whenever you have an open pipe means a pipe that is open at both ends, open here and also open here, and it always starts and ends with an antinode. An open pipe always starts and ends with an antinode. This is an antinode, this is an antinode, antinode, antinode. Where the point they meet is called a node. So this is a node. Okay. Now the next question here. A string fixed at both ends has a fundamental frequency of 100 Hz. What is the frequency of the second overtone? A. 200 Hz, B. 300 Hz, C. 400 Hz, D. 500 Hz. Now the overtone of a string is given as Fn equals n plus 1 times the F naught times the fundamental frequency. So the second overtone is going to be 2 plus 1 times the fundamental frequency, which is 3 times the fundamental frequency. So that means 3 times fundamental frequency is 100, and so that is going to be 300 Hz. Okay, quite easy. Number 22. An open pipe has a fundamental frequency of 150 Hz. What is the frequency of its first overtone? An open pipe has a fundamental frequency of 150 Hz. What is the frequency of the first overtone? For an open pipe has the same frequency of overtone as a string, n plus 1 times f naught. So these are the other options. So the first overtone is f1, is going to be 1 plus 1 times f naught, which is 2 plus 2 times f naught. So 2 times the fundamental frequency means 2 times 150, and that is going to give us 300 Hertz. Okay. Then number 23. A closed pipe has a fundamental frequency of 120 Hz. What is the frequency of the first overtone? The fundamental frequency of a closed pipe, the frequency of overtone of a closed pipe is given as 2n plus 1 times the fundamental frequency. So since we are asked to find the first overtone, is f1, which is 2 times 1 plus 1, f naught. 2 times 1 is 2 plus 1, 3. So 3 times the fundamental frequency. That will be 3 times 120, which is equal to 360 Hertz. So C, 360 Hertz is correct. Now number 24. A string produces a fundamental frequency of 250 Hz. What is the frequency of the third harmonic? The fundamental A, 500 Hz, B, 750 Hz, C, 1000 Hz, D, 1250 Hz. Okay, here the fundamental frequency as given is 250 Hz. Now the third harmonic means 3 times the fundamental frequency. That's the third harmonic. Fourth harmonic, 4 times the fundamental frequency. So this is 3 times 250, and that's going to give us 750 Hertz. So B is the correct answer. Okay, then we have here number 25. An open pipe produces a fundamental note of 200 Hertz. What is the frequency of the second overtone? Okay, A, 300 Hz, B, 400 Hz, C, 500 Hz, D, 600 Hz. Now we write the parameters. The fundamental frequency is 200 Hz. The frequency of the second overtone, frequency of overtone of an open pipe is n plus 1 times the fundamental frequency. And so we are looking for the second overtone, which is f2, is 2 plus 1 times the fundamental frequency, which is 3 times the fundamental frequency, which is 3 times 200, and that would be 600 Hertz. Okay, so that is that. Thank you very much.